4.3, finding the inverse. Switch every x and y value. Here is f of x. The inverse, f inverse of x, would be to switch the x and y values. Instead of 0, -1, we have -1, 0. 0, 1, 3, 2, 5, 3. That is the first step in finding the inverse. If I'm given a table of values, I switch them. That would also be true for ordered pairs. F inverse of x would be 5, 3, -1, 4, and 0, 5. If that is true in a table of values and in the ordered pairs, that would also be true on a graph. My first point is at 2, 3. This is the point, 2, 3. I am looking for the inverse. I would switch those points. 3, 2. I'm looking for 3, 2. Notice the relationship to the line when x equals 1, y equals 1. When x equals 2, y equals 2. This is the y equals x line. It is like a mirror image across the line. You will always see that y equals x. This line is a part of finding the inverse. What is the relationship between these 2 points? They are perpendicular to the line. If I am, let's look at the square here. I see half a square. This is half a square, a triangle. If I am a half a square away, I will be a half a square away on the other side and perpendicular to the line. The next point, I could test my theory without even looking at any points to start with. I am going perpendicular to the line. I am 1 square and a half a square away. I would be a half a square, 1 square away on the other side. Let's test our theory. Can I just look at the picture and find the inverse? This is the point 0, 3. The inverse point would be 3, 0. This is the point -3, 4. That means I will see 4, -3 in the inverse. -4, +1. I am looking for 1, -4 in the inverse. It's important that you understand both concepts of being perpendicular to the line and looking at the coordinate, finding the inverse of the coordinates. The graph of the inverse is always a reflection of the original graph across the y equals x line. I will not graph the y equals x line for you. I will just give you a graph. You're going to have to remember to make sure you're always sketching in the y equals x line because we use it to help us guide us on graphs. I am looking for the inverse of this odd function. Tails are going in opposite directions. I could pick some points. I like this one. It's exactly in the corner of the box. 1, 0. That means 0, 1 would be in the inverse. I like this point. 0, -1, therefore -1, 0. This point that's on the line will be in both of the functions. It will be crossing. You can see the behavior here. It's going out and towards the line. It is going out and towards the line. Starting to sketch what that inverse looks like. I would like to pick one point over here to see a guiding point. I could estimate and say that this was the point 1.754. I'm looking for 4, 1.75. 4, 1.75. There is a guiding point to guide me past that point and out. Here is a point right here, -1, -2. That means that -2, -1. One more down here. -1.5, -4. -1.5 and -4. So -4, -1.5, -4, -1.5. And that's enough to guide me. The function is going out, in towards, and out. We are out, in towards, and out. It is a mirror image. At times, I won't even give you any numbers on the graph. If you can take a function without any numbers on the graph and be able to graph the inverse, it's very easy. You're just looking for those patterns. How far away would I be from the y equals x line? I'm about this distance, and so I'm going to go that distance on the other side. We have found the inverse given a table, ordered pairs on a graph. We have found the inverse with a function on the graph. Now we will find the inverse given an equation, and we follow the same steps. Step 1, switch your x and y value. Switch your x and y. X equals 5y minus 7. Solve for the y term. Y is being multiplied and subtracted. I would undo my subtraction with addition. X plus 7 equals 5y, and then I would finish by dividing by 5. Divide this side by 5, divide the left side by 5. We have y equals x plus 7 divided by 5. The last thing that I need to do is I need to notate that it's the inverse. This is the function y. This says it's the function y. I need to make sure that I notate that this is the inverse. Y inverse would be x plus 7 divided by 5. How do I verify that they are inverses? Verify. You need to prove. You can't just say, yes, they are. You can't just take the function, switch the variables, and solve and say, yep, it's the inverse. When you verify, you're looking for something specifically. I am going to do f of f inverse. I'm going to take the inverse, and I'm going to substitute it into the main function f. Starting with f, y equals 5x minus 7. I am going to substitute in to the x. I'm going to substitute in my inverse. We have f there is our f function, and we are going to substitute in the inverse that we just found. We're going to verify that they are inverses. That would be x plus 7 divided by 5. That is our inverse that we just found. Now I need to simplify. I'm looking for something specific here. I have multiplication is where I'm going to start simplifying. If I make 5 a fraction, I can see that I have a 5 in the numerator that is going to cancel with a 5 in the denominator. And that leaves y equals x plus 7 minus 7. There is nothing outside the parentheses being multiplied. There are no exponents with the parenthesis. I can just drop the parenthesis, x plus 7 minus 7. A positive 7 and a negative 7 cancels, leaving y equals x. How does this verify to me that they are inverses? What does my answer mean? If I look on a graph, we know that y equals x is always going to be a part of the inverse. Even if you don't see it and you're trying to find an inverse, it is implied that y equals x is a part of the inverse functions. You are finding a mirror image across the y equals x line every time. It should make sense then. Our final answer says y equals x. We have f, we have the inverse, and we have the line that is always implied to be there, y equals x. Therefore, they are inverses. Therefore, f of f inverse are inverses. The inverse of a function f is also a function if and only if no horizontal line intersects the graph f more than once. Again, it has to be 1-to-1 in order to be able to have an inverse. If it is not 1-to-1, then we have to do something to it so that we can find the inverse. Here is a parabola. Here is a quadratic. If I do the horizontal line test, I can see that I can't take the inverse of this entire function. Here, if I do the horizontal line test, no matter where I do it, it is 1-to-1. I could find the inverse of this function very easily, as we did on a previous example, very similar, seeing that cubic, tails going in opposite directions. Here, we're going to learn in the next section, what do I do to a function if it's not 1-to-1? How can I find the inverse of a function that is not 1-to-1?